So on our farm, we grow organic sunflowers for oil production. And I also have full-blood limousines for grass-fed beef, which is certified organic for PCO in Pennsylvania. And I always liked the New Yorkers because I was an intern as a veterinarian at Cornell. In ambulatory, so in Trumansburg, I was in Trumansburg. I remember the lake, going around that lake. So why do I do this? Is, by the way, funded by Sarah, and I have to make sure that's in my study farm and sunflowers with Sarah. So as a veterinarian and an organic producer, I take in from the cattle standpoint. I don't raise sheep. So the question is, why do I do a sheep study? Well, it's obvious if you're going to do a parasite study, it's a lot easier to do sheep than cattle. Cattle is a little bit not fun, at least running them through chutes and stuff like that. Sheep, you tell them to go one direction, they all go there. It's a lot easier. So here I am in Pennsylvania, realizing that we don't, and after you start doing some research, you find out that the organic Anthelmintic wormers seem to have poor efficacy. Now, there's some good stuff coming from the south in the sense of research has been done on high-tannin grasses, actually decreasing the worm production and output from the strong bell worms that the sheep get and also ruminants get. And there's also some other things that are happening. There's people, but you look through at diatomaceous earth, you look at garlic, you look at pumpkin seeds, and you look at all this stuff, and it's really quite discouraging if it's ever put to scientific testing. So the current concern I have as an organic farmer is you are obviously worried about genetic selection, you're worried about management, making sure it passes rotations, you're putting them in proper areas, obviously nutritional things. But what happens when you do get that sick? Again, we're not like New Zealand. We have small Pennsylvania farms raising sheep for fiber or for meat locally, so we don't have huge farms. So the loss of just one or two or three or four or five of these young feeders or even used is a significant thing, because as soon as you pull them out and you give them oxytectin or fenbendazole or whatever you're giving them, they're no longer organic and you've lost that time. So I took on this thing. I said, well, this is about to drive me nuts. So I said, let's see if I can think of one as a veterinarian who's been practicing for 26 years of coming with some kind of compound that would maybe have an effect. So I sat down on my farm in Pennsylvania and I said, what is the most toxic plant that I can think of that I could use? And I thought about it and I said, walnuts. Walnuts really stink, They are really nasty with horses, causes laminitis, can cause colics, it's bad, and everybody knows hardly anything grows on walnut trees. So I started focusing on walnuts, and it was interesting because I started to find that there was an anthelmintic or deworming property to walnut hulls, and there was a lot of these naphthoquinones, which if you go to I didn't know I didn't have to have a poster, but I have a big poster down there that shows you what an naphthoquinone, and all my research is down there if you want to look at that. And so I said naphthoquinones, really interesting compounds, and they bypass the rumen. So the next thing was I started digging deeper, and I was mainly interested in Junglone, which is a naphthoquinone in walnut hulls. And it turned out there was a study done in the 1970s by USDA using these naphthoquinones, not necessarily from walnuts, but naphthoquinone compounds, which are aromatic compounds. And it showed that there were specific studies looking at the anthelmintic properties of these compounds. And it looked like Plumbagen turned out to be more effective than the other naphthoquinones. So then I started to focus on Plumbagen. So this started to go down a pathway, and it's actually was starting to lead to something. So I focused on Plumbagen, and I said, well, why don't I try to create a study to test the efficacy of Plumbagen to see if it could do anything. So right away I knew I was going to work with sheep because of the ease, right? And also because we had one nasty parasite, H.Contortus, which sucks blood, which is a nasty one. And 26 years of rescuing sheep from the death out on pastures after spring rise in the summer with the ewes or the little guys. So sheep, Plumbagen. And then I said, well, what kind of compound what kind of way can I get Plumbagen in a potentially organic system. So I was looking for an herbal extract of some nature. And of course, there's no walnut hull extracts that were, I need something standardized so I knew an actual quantity of plumbagen in the extract. And I had to go to China and India as the plumbago species of plants, and plumbago species of plants are standardized as herbal extracts for the Chinese and for the Indians. And I found Plumbago zelenica is a herbal extract, and I have pictures of it down on my poster. And it has 3% plumbago. It's understood and standardized. So now I have an herbal extract with a known amount of the compound I want to test for. So dealing with Dr. Kaplan in the University of Georgia, who I have great admiration for, and has tested a number of organic compounds, he told me that he helped me set up the study. So let me just show you what we did. So for any of you who want to set up an organic, and this has to be done, because if we're organic producers, we need some of these compounds because we don't want to be losing our animals after all the hard work to give them a chemical anthelmintic. So, so the way we set up the, is it page down? Is that what we're using? That's this one. Nope. Which one's page down? Oh, there it is. So the way we set it up was I got 31 lambs from the New Holland auction in Pennsylvania. So these were all feeders in a certain feeder range. They were raising anywhere from 35 to 40 pounds to around 7 to 8 pounds. And the goal was to randomly put these into 3 treatment groups. One would be a control group, one would be a preventative group, and one would be a treatment group. So we get all these sheep together and we treat them all, because these guys are coming from all different environments. We treat them all with 3 anthelmintics, moxidectin, levamisole, and a type of benzimidazole. So 3 different types of chemical wormers that kill in 3 different ways, pretty much guaranteed to wipe out. So we start from 0 with these sheep. So the goal is that we've chemically purged them of worms. We don't want any conflicting worms in the experiment. These sheep were put onto 3 zones in a hay field that has never had any sheep or goats or parasites ever before. This is on a orchard grass clover field with, obviously you can see some milkweed there. So we put them on those 3 sections. So first of all, we wormed them all, chemically purged them. Moxidectin can continue to kill for X amount of time, and I was getting infected H.Contortus L3 larvae, which I was going to dose them with. 5,000 larvae per sheep. So these poor guys were going to get whacked with H.Contortus larvae, sort of to try to imitate a highly infected pasture. So after 3 weeks, we knew we were past the moxidectin killing zone. They were infected, all of them, with 5,000 L3 larvae. There was a preventative group that was also treated with plumbagen and an herbal extract. The next question is, how do you know how much to give? So we knew sort of a toxicity zone of the compound and where we could sort of go. Dr. Kaplan said that he thinks the problem with a lot of the organic compounds is we expect one treatment's going to do it, and that probably you needed multiple dosings to try to do it. So we chose to dose it at a certain dosage that we were figuring out for 5 days in a row. So the preventative group was dosed right when the larvae were given. So I'm trying to see if they're larvicidal. Is the compound going to kill the larvae? So when they're put on the pasture, a month later, do they have any eggs, right? Or do they have a patent infection? So we dose them all, we treat the preventative group, not the control group, not the treatment group. The treatment group is going to be representative ones to try to do something to the adult worms, okay? So we wait a month, and that's when we're going to check egg counts to see if we have patent infections or infestations of the actual parasites. And we do, of course. So we check them at that time, and the goal was then to evaluate the egg counts in all three groups to see, first of all, is the preventative group been spared from the versus the control group, and then at that month zone, we were going to treat, after we knew we had a patent adult infection of H.Contortus, was to treat that group specifically with Plumbagen again for 5 days in a row in the Plumbago xyletic herb extract for 5 days in a row again, and then you take egg counts every week from there on. And then we're trying to see is it work as a preventative? Does it work as a treatment versus the control? So you guys all understand that now. And it's really a pretty cool, simple, and then we were looking at fecal egg counts, and we were also looking at their hematocrits or PCV total solids to see, as you know, or maybe you don't know, H.Contortus is the barber pole worm, and it sucks blood in the fourth stomach of the ruminant, which is the abomasum. And this was of interest also to me because Ostertagia ostetalgi, which is the cattle parasite that I was more concerned with my farm, is again another important abomasal parasite in cattle. So I was looking basically at a strong dial. I picked H.Contortus because it's vicious and working with sheep was easier. Okay, so the sheep were randomly assigned, and we tried to make sure that, in essence, they were randomly assigned, but we also wanted to have sort of the same weight distribution in each group, so I didn't have, because I don't have the exact same breeds, I don't have the in the group, so we tried to randomize it somewhat, so but we also had equal weight distribution through the thing. I didn't do anything for sex. Okay, so let's go down here real quick. Page down. There it is. So there's the groups put into their pastures. This is the H.Contortus L3 larvae that we got from University of Georgia. This is the Plumbagen, which is made into a solution that was very water soluble. There was a little bit, you shake it up and you would dose the sheep. We would get the sheep into their representative pens so we could work with them. So one group, like this group, would have been the treatment group, and then we had other groups that were controls. Here we're dosing either L3 larvae or we're dosing them with Plumbagen, and then we would dose them for 5 days.
So Sam, I'm sorry, were they in different pastures?
Yes. Separate
the
pastures.
control group was in one pasture, the treatment group was in another pasture?
Right, so if you go back, you would see there's a little line here. This is actually all of the control groups or preventive groups pastures, but we split the pasture initially and rotated them so that we would have, they've been infected. So I'm not counting on the pasture to provide the parasites. I'm working specifically on the infection I gave them. So I would rotate the sheep because if you guys remember, at least in Pennsylvania, July was wicked and we were like baked. And there was a huge drought in Pennsylvania, so we would have to rotate because if I let them focus on one spot, they would be in trouble. So they had access for a period of time and they were rotated off to their other section and then it was opened up.
Like how long was the rotation?
Rotation was roughly every 2 weeks. So the first thing that came out of this, again, we had the sheep numbers, and then this is egg counts that are averages, and then if you multiply by 50, it gives you eggs per gram. So example on this group was a control group, and this was a month after when we infected them in June, a month later, where the egg counts taken, and then every week beyond that, we took egg counts and hematocrits for the groups. But let me go through this. We'll go to the chart, and then we did their PCVs and total solids. Now, I have to forgive because, and I know Carol will be angry with me, but we don't know if there's physical significance with this yet. Dr. Kaplan's working on that. But we did see a difference that emerged, and we have to see if it's statistically significant. First of all, there was no benefit with Plumbagen in stopping the larval infection, period. So they had high egg counts as well as the control group, no difference. We wormed the treatment groups were wormed in June, and we noticed in July that there was, the treatment group is green and the red group is the control. And we started to see differences in egg counts initially, and they're high egg counts yet. So, but the question is it a statistical difference, and are we doing something? It obviously didn't kill all the worms, but it seemed like it was affecting the egg count numbers. So the egg count numbers we were getting for the treatment groups seemed to be lower, and if you look at the numbers, it was about 60% less of the increase in the amount of eggs, fecal egg counts versus the control group. So that was sort of cool, and the question is it real? We also noticed that by the end of August, the beginning of August, so this is really going over for about a month and a half zone, that and this may not be necessarily significant, but again, the control group did have more loss of blood, was becoming more anemic than the treatment group, which was probably might be associated potentially with the egg counts we were seeing. All the sheep were pulled from the study because the goal of the treatments was when you treat, you want to do egg counts every week, and our goal is to do 3 egg counts beyond, so 3 weeks beyond the initial thing, mainly to see, first of all, did we see an increase, a drop of egg counts, and then we did a week after that, did it maintain a low egg count, or did it happen, and then was there ever a rebound, and that's why we did 3 weeks after. So, we can keep you tuned to see if we think we have statistical, because I'm not a statistician, I'm a veterinarian and a farmer, and we're waiting to see if these numbers are statistically significant. If it is, how would you use it? It appears, again, we can play with the doses. My gut feeling is it didn't have a direct killing effect on the adult worm in the abomasum, but it might have had some kind of delayed reproductive effect on egg laying in the animal. I don't know. So we'll keep you tuned, and I'm going to be talking to Nova Vermont on comparing all the organic Anthelmintics to see if there's what is actually out there in efficacy.
You had an animal in the control group number 13, animal that didn't have later scores. If you go to your first slide. Okay, so that number 13.
Do you want that? Do you want the hematocrit or egg counts?
No. Okay, he was just clotted. Okay, that's why he didn't have it. So.
No, number 13. I didn't have. I think this is the one.
Or go back to the previous slide. Is that the animal? Did that animal die?
Yes.
Okay. So if that animal had stayed alive, given the trend that animal was doing, he would have provided more egg contamination to that field if the trend you were seeing from the 17th to the 22nd to the second carried on. So you might even have had more egg contamination.
We don't know why he died. Again, it was in July. It was a brutal heat.
Right. So that could have been, but also he had a lot higher count than everyone else, because these counts are before you multiply by 50.
That's right. That's right.
So
I just wanted to because it was easier for
so
me.
he was carrying 20,000 or something, so quite a heavy load. Because my only question is, we did a study with Episode, hoping to see it as an ovicide. We knew it wasn't very good at killing larvae in the animal. But we felt that we had to have replications of our pasture rotation systems, because there would be too much chance that what we were seeing going on, that might have been a better trained field than the different part of the hay field and stuff like that.
Well, the field
appeared very uniform.
It was all uniform.
But they weren't. But they weren't going across. So that would be. It seems like when you're looking for ovicidal trends, you want to have some reps of those actual plots as well.
Right.
But given that animal died on you, if that animal had continued, you might have actually seen a greater increase, than you did.
That's true. But
obviously you can't
we gave these guys a pretty vicious dose of H.Contortus, so.
No, but what I'm saying is that.
No, I understand what you're saying. Sure.
Yeah.
Yeah.
So interesting.